In 1977, NASA launched Voyager 1 and 2, two space probes designed to explore the outer planets and beyond. Almost half a century later, these spacecraft have uncovered something extraordinary: a wall of fire, a zone of superheated plasma at the outer boundary of our solar system, where the sun's influence gives way to interstellar space. With temperatures ranging from 54,000 to 90,000 degrees Fahrenheit, this region is revolutionizing our understanding of the Heliopause, the boundary between solar and galactic space. This phenomenon, recorded by both Voyagers years apart, proves to be a lasting and critical feature of our cosmic neighborhood. The Heliopause is the invisible frontier where the sun's solar wind, a stream of charged particles constantly flowing outward, slows down and eventually yields to the interstellar medium, the thin gas and dust between stars. Scientists once believed this shift was relatively smooth and straightforward. That changed in 2012 when Voyager 1 crossed the Heliopause and reported unexpected findings. Voyager 2, which made the same crossing in 2018, confirmed them. Instead of a clean transition, both probes recorded a thin plasma zone with extreme temperatures between 30,000 and 50,000 Kelvin, equivalent to 54,000 to 90,000 degrees Fahrenheit. It's not a literal wall or a fire as we know it. In fact, the particle density is extremely low, far lower than any vacuum we can create on Earth. But the energy of the particles is immense, moving at such high speeds that they register as searing hot temperatures. Scientists believe this heating is caused by compression of the solar wind as it collides with interstellar particles, along with a process called magnetic reconnection, when magnetic field lines from the Sun and galaxy snap and realign, releasing bursts of energy. The fact that both probes found this zone, years apart and in different locations, shows that it's not a fluke. It's a real, consistent feature at the edge of our solar system. But that's not all. The Voyagers also made another surprising discovery. The interstellar magnetic field beyond the Heliopause is aligned with the Sun's magnetic field inside it. This was unexpected. Scientists previously assumed the fields would be randomly oriented, reflecting separate environments. Instead, the findings hint at a deeper, hidden connection between our solar system and the galaxy around us. This upends the old view of the Heliopause as a stable shield. Instead, it's now seen as a dynamic and turbulent region where solar and galactic forces clash and interact in complex ways we're just beginning to understand. The discovery of intense plasma heating challenges previous models and points to widespread magnetic reconnection, the same process responsible for solar flares and auroras, happening on a galactic scale. The alignment of magnetic fields adds another mystery. One theory is that the Sun's magnetic reach might extend farther than we thought, subtly influencing nearby interstellar space. Another is that the interstellar magnetic field has its own coherent structure that interacts with our solar bubble. This matters because the heliosphere, our Sun's protective magnetic envelope, shields us from dangerous cosmic rays, high-energy particles from deep space. If the Heliopause is more active and permeable, it could change how much radiation reaches Earth and other planets. These discoveries also reshape how we think about space weather, not just within the solar system, but on a galactic level. Understanding the Heliopause's true nature will help us better predict radiation levels in deep space, a vital concern for future crewed missions venturing beyond the solar system. This new knowledge transforms the Heliopause from a simple barrier into a complex interface, an energetic region that physically links the Sun to the galaxy around it. It also prompts new priorities for future space missions. For one, it forces scientists to recalculate the scale and behavior of the solar system's boundary. Engineers now have to account for this hostile environment, intense plasma, magnetic turbulence, and high-speed particles when designing future interstellar spacecraft. One of those missions is IMAP, the Interstellar Mapping and Acceleration Probe, set to launch soon. IMAP will investigate the very same processes the Voyagers uncovered, using new, advanced instruments to map how solar wind meets interstellar space and to unlock the secrets of this mysterious boundary. Beyond our solar system, these findings offer a cosmic perspective. If our heliosphere behaves this way, other stars likely have similarly complex outer boundaries. Studying these zones helps us understand how stellar systems protect their planets and interact with the larger galaxy. Most of all, this discovery highlights the incredible legacy of the Voyager missions. Launched decades before the digital age, they're still sending back data that's changing science. While NASA has started shutting down some instruments to conserve power, both spacecraft are expected to remain operational into at least 2026, continuing to push the frontier outward. Their findings raise big questions. How far does the Sun's influence extend? How does our solar system interact with the galaxy? The answers will reshape how we view our place in the universe. Nearly 50 years after launch, the Voyagers are still rewriting the rules of space science, revealing a searing plasma boundary at the edge of the solar system, and hinting that the galaxy beyond is far more connected to us than we ever imagined. What other secrets lie beyond the Heliopause? Stay curious. The real frontier is just beginning.